Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. Today we will take lecture number 27 of the subject of software engineering, in which we will discuss the software matrix. Here we will discuss the types of software matrix and the defect removal efficiency matrix as well. Dear students, software matrix is very much complicated and very much vast topics. So we are going to discuss it into another lectures as well. So in this lecture, we will discuss the matrix, measurements of the matrix, why measurements of the software, the matrix examples, a good manager measures, and a process of matrix and the software process improvement, factors affecting the software quality, project matrix, product matrix. Now the question is, how big is the program? For example, if someone asks from you that what is the size of the program or how big it is, usually for example we says that the road is 20 kilometer long, or we say that this building is 15-meter high. So we will say that this is the size of the road and the building. So for example, how we can express that the size of the program? So usually we say this is the small program or huge program, but this is not sufficient. Similarly, another questions may arise. For example, how close are you to finishing? That means how much work you have done, how you are near to your project's completion. So we will say that we are almost there, or we will say that I have completed the project. Similarly, can you as a manager make any useful decision from such subjective informations? For example, these are the subjective information. For example, huge, almost done, very small project or very large project. These are the subjective information. These are not the quantitative informations. So we need information like cost, effort, size of the projects. So all these should be in the numerical format. If they are not in the numerical format with us, we cannot make any sort of the decision about the project. So that's why there is the need of software matrix. Now matrix. So how we can define the matrix? Basically, matrix is a quantifiable measures that could be used to measure the characteristics of a software system or the software development process. Basically, it measures the software system and also measures the software process. Software system means that product which we are going to develop, and the process means that methodology and the life cycle model which we will use to develop the software. Basically, metrics are used in all phases. In fact, this is the measurement which should be done in all phases of the life cycle models. And it's also required for effective management. Effective management can only uh, perform their management activities while they have efficient information about the matrices. So manager need quantifiable information and not the subjective information. They need the quantifiable means that some measurement numerical information or statistical information. They don't require any sort of the subjective information. So because subjective information cannot express its the particular value completely. Subjective information goes against the fundamental goal of the engineering. For example, in the civil engineering, we says that the speed of the aircraft is, for example, particular miles per hour, or the speed of the car is, for example, 90 miles per hour. So that is the in fact, subjective. That is the quantifiable informations. But we can say that the uh, today is very hot season, or we can say that it's very temperature is very low or it's very cold. So these are the subjective information. These are not quantifiable information. But in engineering, subjective information cannot be used. We should use the quantifiable information to make the decision. Now, what is the measurements? In the daily life, we perform many sort of the measurement. For example, when we want to measure measure our running, so we use the stopwatch and we in fact are count our steps. So that is the measurement. Or we use certain machines which in fact measure our speed of the running as well. So measurement is the fundamental to any engineering discipline. In the any engineering discipline like software engineering, measurement is very fundamental entity. It is used in many places. So software metrics is broad range of measurement for the computer software. The metrics are in fact used for to measure the computer products or the softwares. Software process measurement can be applied to improve it on the continuous base. For example, in a software process we have many phases, right? Like requirement engineering, like in designing, implementation, testing, and operation phase. For example, in the testing, we says that 100 bugs were identified during the testing, and we have fixed 90 bugs, and still 10 bugs should be fixed. So these are certain sort of the measurement. Similarly, in implementation, we says that one programmer perform 1000 line of code on the weekly basis. So this is also another sort of the measurement. So software projects measure can be applied in the estimations, quality controls, productive assessment, and project control. Basically, the project matrix, which is a very special sort of the matrix that is relevant to the project by itself. So it is the estimation of the quality control. For example, how the system should be reliable. So here we perform the quality control matrix such as reliability. If the unwanted user or the threats attacks the system, so what is the capability of the products that they have repel the threats. So this is one types of the quality control matrix. Productivity assessment. Productivity assessment means that how how is the programmer productivity in terms of days or weeks. So how many line of codes are written by the programmer for the particular projects. So this is the productivity assessment. And the project control, overall we control the projects through using our scheduling and the price controlling. Also we can control the budget of the project. So measurement can be used by software engineers in decision making. For example, if there are many bugs occurring in the project, so that means the projects may be failed or may be cancelled. So the managers decided to cancel the projects if there are many bugs, and also manager decided to continue the project is the if the project has high reliability and portability and efficiency. So we can say that the project is going towards in the good direction, so the project manager will continue the project. Okay, why measure the software? Why we want to measure the software? These are very key questions, and the answer is here that determine the quality of the current product or processes. So we want to in fact achieve the quality. The main focus is on the quality of the products. For example, there are many international standards who works for the quality like IEEE standards, CMMI standard, ISO standards. So all these standards work for the quality. They measure the product and the process, and also they perform quantifiable matrices using the product and process so that we can achieve the quality. It also predicts qualities of a product and process. So if you have certain metrics and you know about them, you should just put the values and you can assesses the product and process for the quality of the product. Also, it improves the quality of the product and process. So when we in fact apply the metrics, we can improve the quality of the product and process as well. Now the definitions. It measures quantitative indications of the extent, amount of dimensions, capacity or size of some attributes of the product or process. For example, number of errors. Basically, it is the quantitative measurement. For example, amount, dimension, capacity of size of some attributes or a product or a process. Measurement that act out determining a measure. So basically, this is the measurement which is the determining particular sort of measures. And the matrix is a quantitative measure of the degree to which a system, component, or process possesses a given attributes. For example, number of errors found per person hours expended. So when we provide the measurement to the matrix, we can measure completely the process which has certain attributes. For example, number of errors found per person hours expended. If the particular persons found many errors or his or her works has contained many errors, so we will say that the process is contributing very slowly. So using or identifying the errors, we in fact find out the matrix which will help us to find out how the process is going for the proper direction or it's on the right direction. Okay, now there are another definitions including indicators, direct measurement, indirect measurement, and the faults. So what are the indicators? Basically, an indicator is a matrix or the combination of multiple matrices which provides insight into the software processes, software project, and the product itself. So, for example, indicators are those attributes which in fact help us to find out the insight into the processes, projects, and the products. So basically, using certain indicators, we measure the software quality by using the process, project, and product matrix. Direct matrix immediately measures attributes, for example, line of code, execution speed, defects reported. The direct matrix is that types of software matrix which immediately measures the attributes of the software products. That means that these are immediately available with us. So, for example, the line of code. We can count the line of code by using different sort of the compilers. If the compilers has a certain ability that it counts the line of code, that automatically it will give us line of code matrix. So also the execution speed of the softwares. So we can here measure the efficiency of the software through the execution speed, that how much time it has taken on the CPU. And also we have the defects reported during the testing of the projects. The defects may arise. So here the quality assurance personnel may report the defects that occur in the project. So these are called the direct measurement. Basically, the direct measurement is in fact obtained from the products. So executing the product and analyzing the products, we get all such sorts of the measurements. Another one is called indirect metrics. Indirect metrics is the aspects that are not immediately quantifiable. So these are non-quantifiable attributes, while the above direct metrics were quantifiable attributes. It contains the functionality of the products. So we here will count down different, in fact, functions in the products. Then we have the quantity. The quantity means that here we have certain quantity, that number of operation performed by the product. And then we have the reliability. Reliability means that here we have certain sort of the reliability attributes of the products, that the system will work in every seconds of times and it will not stop working. So that means that is 24 by 7 approach will be followed, that the system will always be the up and it will never goes into the down status. And then we have the faults. Faults are certain sort of the defects that can occur in the usage of the project. So there are two types of faults. One are the errors and second one are the defects. The errors are those faults found by the practitioners during software development. The practitioners means that the person who developed the software, it is also called the programmer who developed the software. So they if identify certain faults and these are called the errors. And remember that without the errors, the software will not be executed by the compiler. So the errors are very much fatal problems in the software. Another types of faults are called defects. Defects found by the customer after releasing. So defects are those problems when the customer identifies some sort of the bugs or some sort of the defects in the projects. For example, system will work correctly, but it will give us wrong results. These are called the defects, and these are mostly identified by the customer. Why do we need measurement? So why we want to do measurement here? First of all, to indicate the quality of the products. So we must have to do the measurement. For example, if we want to find out the defects in the system and we count the number of defects in the system, that will shows that how much is the quality of the product. To assess the productivity of the project who produce the product, so here we will assess the productivity of the people who in fact develop this product. People are, for example, developers here. So here we will assess their productivity, that how much line of code one person is going to complete in one day. So that will be the productivity of the people. Here we will in fact guess that in which date the system may be completed by using the productivity of the people who produces the product. Next one is to assess the benefits derived from new software engineering methods and tools. Here we will assess the all sort of the benefits that we have in fact adopted from the software engineering methods and tools. Every methods and tools in fact provides us measurements. So all these measurements are in fact used for the benefits, that how we are going to achieve the business goals of the users, to form a baselines for the estimations. Here, metrics help us for the estimation purposes, that we can estimate the projects, that the time required to complete the project, the schedule required to complete the project, and the budget required to complete the project. To help justify requests for the new tools or additional training. So here, in fact, when the new tools or additional training is required by the developers or our staff members, then it the software metrics will help us to identify that there is need of new tools and also additional training. For example, if the productivity of a programmer is day by day becoming low and low, so we will think about the additional training for the programmer, and also we will think that there is the need of new tools because the previous tools is not much helpful for the programmer. Similarly, estimate the cost and schedule of the future products. If we want to estimate the costs, cost means budget, and schedule means time frame are required to complete the project for our upcoming projects. So the previous matrices will help us for predictions. For cost, the future staffing needs. So current metrics will help us the future needs of our staff members. Anticipate and reduce the future maintenance needs. If we have certain maintenance required for our tools and technologies, so using the matrix, it will also help us to anticipate and reduce the future maintenance needs. Because if we have a good to quality tools and additional trainings for our staff members, so we do not require any sort of the maintenance for our tools. Now, matrix examples. Here we will see different examples of the matrix. First one is called defect rates. Defect rates means number of defects occurring while using the project by the customers. Also we have the error rates. Error rates means the errors that occurs while using the projects by the customers. These are errors which are encountered while using the project. Next one is measured by. Who measure the matrix? Measurement is provided by individuals and also provided by the modules, and these are provided by during the development. So in every phases we in fact takes the measurement during the development. Errors should be characterized by origin, types and cost. All the origins which are occurring in our projects, they are characterized, they are the type of the origin, type and cost. So all errors that will be either of the origin means that by the products, the errors occurs in the products. The errors may occur in the type of the products. For example, it is web product, it is database products. So are have different sort of the errors. And cost. Errors also are in fact characterized by the cost. If the project is of the high cost and lengthy project, then there may be more chances of the errors. If the project is very small and of the low cost, then we can say that there will be no errors or less amount of errors in the project. A good manager measures the process metrics, project metrics, and the product metrics. So these are in fact called the types of measurements or the type of matrices. So for example, process metric, project metric, and product metrics are very much important types of measurements. So what do we use as a basis? The size are the functions. Size means line of code in the program. So early user of the size or the line of code included the comment statement. Nowadays, the comments are not executable statement are excluded from the size. And the functions are the functionality or the number of services that we have counted in the projects. So these are called the functions. So either we use the size or function by providing all sort of the measurements. So not everything that can be counted counts, and not everything that count can be counted. This is the Einstein statement about the matrix, that it is not possible that what we are counting is a counts, and what we are not counting are not counts. So in fact everything is important. Einstein says that measurement is very much important for us. Without the measurement we cannot identify our the problem, and we cannot know about everything. For example, the sun is very hot, so this is also one of the subjective measurement. But how much it is hot? For example, the sun is 5000 degrees Celsius hot. So we can say that the sun is very hot. So that's why measurement is very much important. Okay, now the process matrix is a matrix which is relevant to the development process. For example, waterfall model, prototyping model, spiral model, these are all called processes. So overall development time and type of methodology used is the example of the process matrix. So what is the overall development time? Means time scheduled to require to complete the projects, and the types of methodology used to complete the projects. Methodology, for example, object oriented methodology or structure oriented methodology. So here we will define the implementational methodology that will be used by the project. Uh, Process metrics are collectively across all projects and over a long period of time, because the process is very much lengthy. For example, waterfall model has 5 lengthy phases, while the spiral model has 4 very big quadrants. So that's why process matrix takes a lot of time to measure. So that's why it's very much important, but it requires a high skilled person to perform the measurements. So their intent or the purpose is to provide indicators that leads to long-term software process improvement. So once we have a process and we have performed some measurements from that process, we can use that measurement in the future processes as well. And these will act as indicators for us in the long-term software development. Process metrics and process software process improvement. Basically, the process metrics are used in the improvement of our software processes. To improve any processes, the rational way is measure specific attributes of the process. We should measure all attributes relevant to the process. For example, the cost attributes are the schedule attributes that is uh, assigned to a particular activities in the software process. All these should be measured. Derive meaningful metrics from these attributes. Then we will use certain formulas which are internationally known equations for the matrix. We should derive values for this particular measurement. Use these metrics to provide indicators. And using these metrics, when we will in fact make the measurement through using these metrics, then it will gives us indicators that whether we are going towards the right direction, and we are in fact doing our business very well, or we are in fact drifting towards our towards the failure. So that's why indicators help us to assess the process. To, the indicators lead to a strategy for improvement, and this indicator later on used for the improvement of the software process, because project manager will next decides about these indicators that whether we have to follow this process or we have to switch towards a new process. For example, we have agile process, we have scrum process. Similarly, we have the CBD model, component based software development model. So whether we have to change the process or the current process is good for us. So that is in fact provided by the indicators by using software metrics. So process metrics has many examples. So basically process metrics focus on the quality achieved as a consequences. Later we will give this example of the process metric, but first of all the process metrics provides a quality achievements, and this is consequence of the repeatable or managed process is because of the process matrix. When our process is repeatable means that it should be executed more than one time. Our managed process means that the project proper project manager is responsible to monitor and manage the process. Then the strategic and long term process can be defined. So all the processes which are in fact long term and strategic processes, they must have some process metrics as well. Statistical software process improvement, SSPI, error categorization and analysis. These are certain sort of the matrices that are used by the process matrix. In SSPI, error categorization and analysis includes all errors and defects are characterized by the origin. So all the errors and defects that are encountered by using this product is in fact used by SSPI, error categorization and analysis. The cost to correct each error and defects is recommended. So when the errors will occur, we must have to correct these errors or fix these errors, and also the same with with the defects. So these must be recorded, and also the cost of the correction, that is the maintenance and the defect maintenance cost must be recorded. This is also an example of the matrices. The number of errors and defects in each category is computed. The number of errors and defects that occurs in the project for each category should be counted, and they should be documented. Data is analyzed to find the categorization that result in highest cost to the organization. So using all these information, the data is in effect analyzed. So all the data of the matrix should be analyzed to find out that the result in the highest cost to the organizations is in fact in the favor of organization, or it is in against the favor of the organization. Okay, plans are developed to modify the process, and then we in fact make different sort of the plans for modification of the current process. Now defect removal efficiency is very much important matrix. Basically it helps us to identify the defects, and it will provides a particular percentage values that will says that whether the project is defect free or it is full of the defects, right? So DRE is an equation, defect removal efficiency. So rational relationship between errors, E for the errors and D for the defects. It is in fact a formula which has certain relation of the E and D. So the ideal value is 1, because if E divided by E plus D and we obtain 1 from it, then it means that the project is error free. So when it will be error free? Uh, when we have one error and no defects. So 1 divided by 1 plus 0 is equal to 1. Or if we have the same number of errors that we have and no defects occurs. So here, for example, if we have same number of errors and no defects occur, its value becomes 1. Or if we have if errors and defects are the same, for example 10 errors and divided by 0 plus 10, it means that defects are corrected, errors are corrected, and now they are defects. So that means defects are in fact those errors are the faults which are encountered while using the project, while errors are those faults which are encountered, they are in fact coming are notified while developing the project. So errors will be fixed, but when the project is launched into the market, then these errors are called defects. So if the value of D is 0, that means that it will gives us 1, which is the ideal. Means that the customer do not identify any sort of the errors in the usage of the project. For example, suppose that we have 100 defects and were found during quality assurance testing stage, and 84 defects were resolved by the development team at the moment of the function measurement. So the DRE would be calculated as 84 divided by 100 is equal to 84%. So if we have the 100 errors, 100 defects and 84 were defects, then we have 84 divided by um, that is the 84 divided by 84 plus 16. 16 are in fact defects and 84s are, that is 16 are errors and 84s are defects. So that is 84 divided by 100 is equal to 84%. Now factors affecting the software quality. There are three factors which affects the software quality, and these three factors are in fact combined in one thing which is called the process, the product, people and technology. So these things are affecting the quality. So if we have a good people and we have a good technology for the development and also we have a good processes, then we obtain a high quality products. So customers is connected with the product and the people, while technology is connected with the process and the product. So this is maybe the development environment, and the development environment contains some sort of the compilers and the interpreters and database management systems. By using the development technology and good business condition and also good characteristics of the customers, we can develop high quality product using good technology and good process and the skillful people. So all these things are affecting the quality. So that's why all these information must be measured. Now, how to measure effectiveness of a software process? To measure the effectiveness of a software process indirectly, we derive a set of measurement based on the customers that can be derived from the process. So in fact here we measure the effectiveness of the software process indirectly, not the directly. Means that we indirectly measure it through the functionalities. So we derive a set of metrics that are based on the results that has been derived from the process. So different processes phases are measured here, and then we find out that whether we are achieving the quality or not. Outcomes includes error uncovered before release of the software. That means all errors which are in fact uncovered and not handled while the system was released. So that is also one sort of the matrix which shows that how much the quality of the software should be bad. Defects delivered to and reported by end users. So when the software is launched into the market and provided to the customer for usage, then the defects may occur. And if they are reported by the end users, then we will say these are the defects and these are very seriously. So all the problems should be solved within the software development environment and within the organization, and should not be delivered to the end users until they are clean from all sort of the defects. Work products delivered. Here we have the productivity, that what is the productivity or the speed of software development by the developers. Means that how much line of code the developers are producing in one day or in 1 week. Next one is the human efforts. Human efforts is also the same. that how much hours they are spending for the development per day. Similarly, calendar time means that overall time required to complete the project and conformance to the schedules. So the calendar time much should be confirmed to the schedule that whether we are following the schedule or the schedule is slipping. So these sorts of the measurements are included in the software process matrix. Next one is the project matrix. Project matrix is that matrix which are the indicators which obtained from the projects. So project metrics are the measure of the software project and are used to monitor and control the project. So here the project manager must have to control and the monitor the project. So using this measurement, they in fact uh, make communication with the projects. By this way, they do their measurements, and these are called the project metrics. They enable a software project manager to minimize the development time by making the adjustment necessary to avoid delays and potential problems and risks occur in the project. So, in fact, using these matrices, the developers want to minimize the development time and make some adjustment which are very much important to avoid the delay of the development and also the potential problems that occurs while the development of the projects and also that factors which affects the quality, cost or schedules of the projects, and they are called the risks. So all these problems may be resolved by using the project matrix. So assesses product quality and on an ongoing basis and modify the technical approach to improve the quality. All these assessment then we takes from the project matrix are used to assess the product quality and also to modify the technical approaches and methodologies used to improve the quality of the product. The project metrics are used in estimation techniques and other technical works. Basically, we use the project metrics to make the estimation and other technical works. Metrics collected from the past projects are used as a basis for the which efforts and time estimates are made for the current software projects. All metrics are used for the estimation purpose and the past project estimation can be used in the current projects as well. As the project proceeds, actual values of the human efforts and calendar time expended are compared to the original estimation. So whenever the time proceeds, we in fact make the measurement and we compare the actual measurement and the measurement that are provided by the matrix and we compare them. So if they are coinciding, that means that we are going in the right direction. If the actual measurements are in fact very much different from other our measurement of the matrix, then we will say that we are in fact slipping towards the other sides and the project is going towards the failure. So this data is used by the project manager to monitor and control the project. So all these information of the project matrix are used by the project manager to control the project. The project metrics have different examples. So the project metrics are usually used by the project manager and software team to adopt the project workflow and technical activities. And these are the metrics of the projects. It includes efforts or time per software engineering task. So all the efforts and times that are in fact consumed while developing the software engineering task here means that software engineering functionalities. So that means that all the functionalities of the products that we are going to develop using the software engineering techniques. So here we will measure the efforts and time required to complete these activities. Errors uncovered per review hours. As you know that in the agile methods, one reviewer perform the review of the code while the other one perform the coding at the same time. So that means that errors uncovered per review hours. So and sometimes when a programmer perform complete coding, the another person then review the code of the that programmers. So that errors may occur. So what is the efficiency of uncovering the errors or identifying the errors? Here, this is the matrix which find out the errors per review hours. For example, in 1 hour reviews, how many errors have been identified? Schedule versus actual milestone dates. Here we will first of all make the estimation, that is the estimated schedule, and in fact actual milestone dates. We will compare all these. If they are coincides, they are similar, then we will say that we are following schedule. And if they are different from the schedule, means that we are late. So that means project may be late. Number of changes and their characteristics. So in the projects, sometimes the changes are required. Changes here means that if the customer rejects the particular functionality or the module, then we have to repair or maintenance is required. So then the changes must be required. So how many changes are occurring and their characteristics of the changes. Distributions of efforts on the software engineering task. Here we will distribute the number of people involved in software engineering responsibilities, and here we will show how we have distributed the people for the software engineering task. Next one is the product matrix. The product matrix are the measure of the software product at any stage of its development. Here we will in fact measure the product, the attributes of the products, and we will gain important information from the matrix using the particular attributes of the product. From the requirement to install the systems, from the early phase of the software, which is the requirement analysis and specification, until the system is launched in the market and used by the users, which is the installation phase of the system. All the informations and matrices that are gathered during these phases are called the product matrix. Product matrix may measure the complexity of the software design, how much the software design or the product is very much complex, how many modules are there, how they are interfacing with each other, number of interfaces and communication lines of the modules, etc. The size of the final program. Final program's line of code is measured here, which is in fact the line of code matrix excluding the comment statements. Only executable statements should be counted in the size of final program. The number of pages of documentation produced here. In every phase we produce some sort of the documentation. For example, software requirement specification document, software design and description document, similarly the test case documents, and similarly the help manual for the user. All these are called documentation. How many pages of documentation produced, it also is one type of matrix, and this is the product matrix. Now, importantly, types of software measurement can be direct measurement and indirect measurement. As already we said, the direct measurement is quite easy to collect. For example, cost or the budget, effort, time required to complete the project, line of code, number of executable statements in the program, execution speed, that is the performance of the software product. Similarly, memory size, when the software is installed on the computer, how much GB means gigabytes are taken by the software. Defects, etc. Defects are those problems that may occur while using the projects. So all these are called direct measurement. And in indirect measurement, we have more difficulties to assess and can be measured indirectly only. These are very tough measurement as compared to the direct measurement, and it is very much difficult to assess correctly from this indirect measurement. It contains the quality attributes of the software, the number of functions in the softwares or the functionalities in the software. Then we have the complexity of the products, that how much the software is complex, and also how the geographical user interface is very much complex. Reliability of the softwares, it means that the software is in fact keeping it safe from the unwanted user, or it's is safe from the threats that may be encountered while using. For example, the system is very much reliable and it works in every uh, moment of the its life of the services. Similarly, the efficiency means how the software is efficient and it's very much effective in the execution of its different operations. Maintainability means the software is quite easily repaired and is maintainable. So these are called different sort of the matrix. Yes, student, this was the introductory lecture about the matrix. Here we have just defined different sort of the matrix, and also we have defined the defect removal efficiency matrix. Now this is the end of this lecture. If you have any question, you can ask through the email. My email is m.kadim@kust.edu.pk. I will answer your questions immediately if I receive your emails. And also, if you want to read more about these topics, there are the book references that I have taken all the information from these books. Thank you very much.